Hi everyone. In this video we're going to talk about energy density. Energy density is all about the amount of space that different sources of energy take up. And one of the things that we're going to look at is how high energy density sources have many advantages over low density sources. This doesn't mean that low density sources are bad, but it does mean that there are problems that we have to manage if we want to use those sources effectively. Let's begin with a definition of what energy density means. When something is energy dense, it means that we can generate a lot of energy without too much space. So low density, by contrast, would mean that we need much more space to generate the same amount of power. Another way to think about this is that when something is energy dense, it packs a bigger punch, or it's a mightier package in a smaller size. And there's lots of different ways to understand energy density as we compare different sources of electricity. But before we get into that, I want to illustrate this idea with a non-global warming example. And this is the example of food. So what I did is I looked up the calorie count, which is a measure of food energy, for 100 grams of chocolate. This would be the size of a 100-gram bar. And this bar that I hold in my hand has about 535 calories. So this is probably about an hour of fairly vigorous exercise that you could burn off with that many calories. So this packs quite a bit of a punch. And as you can see, I can hold it in my hand and it doesn't take up much space. Chocolate is calorically or energy dense. Now, I compared this to how much lettuce you'd need to eat to get the same number of calories. And based on the calculator that I found, it takes about 3,560 grams, about 3.5 kilograms or 8 pounds of lettuce to give you the same amount of energy. I do not have 8 pounds of lettuce to show you, but that would obviously fill a good sized grocery bag. It would take up a lot more space. Lettuce is not energy dense. It has other advantages and it's nutritious, but it doesn't have the same number of calories. And in a similar kind of way, when we're talking about the energy density of different sources of power, nuclear, coal, natural gas, and the like, we're essentially talking about if it's energy dense, it will fit a lot in a small package, or it's not going to take up much land space. If it's less energy dense, there's a potential that it could take up a lot more land space. So in the chart below this video, there's going to be reference to something called life cycle analysis and the energy density or the amount of space that different sources take up. In a life cycle analysis, what researchers try to do is to estimate the impact of something basically at all stages of its creation. So for example, a life cycle analysis of chocolate would consider things like the land that's cleared to make the farmland, the fertilizer that's applied to it, how much energy it takes to transport the chocolate from where it's grown to the factory to process, how much it takes to transport that chocolate from the factory to the grocery store, and how much energy me as a shopper would need to spend to get that. So a life cycle analysis of the energy it takes to create chocolate would take all of those steps into account. When we're talking about energy density, the process is similar, but scientists try to estimate the amount of land that are needed for different parts of the process. So this would include things like the resources that we need to make our power plants or other sources of energy. So how much resources and minerals it requires to manufacture a solar panel or build a wind turbine. This would also include the land of the power plant itself, and also the space that's taken up by the mining. So for certain things like coal and natural gas, we need to get resources out of the ground. The life cycle analysis takes that into account. Finally, many sources of electricity and energy will generate waste. Nuclear waste, for example, but also when a solar panel stops working, we'll need to put it somewhere. So we'll need to landfill it. So what the life cycle analysis and energy density tries to do is it tries to count all of these different things and ask, how much space are we going to need to generate similar amounts of power? So as I directed in my previous example, there's a number of things that we need to take into account. Extraction is a big one. So this would include not only the fuels, but also the resources that we need to build the different energy sources or the power plant. And this would include things like the space that's taken up by mines and limestone quarries. So cement is one of the products that we make from limestone, and a lot of our power plant buildings, like nuclear reactors, are built using cement, and many things like solar installations and windmills require cement to anchor them securely to the ground. So extraction would include all of the steps of this process. Then there's the direct footprint that's taken up by the power plant or the energy installation itself. So if you were to put up solar panels, this would include basically the land under them. If you were to build a nuclear power plant, this would include all of the space for the nuclear reactor and all of the electricity generation that takes place there. If you're looking at a hydroelectric dam, this would include not only the dam, but also the water behind it, the reservoir that you hold to be able to generate that hydroelectricity. And again, disposal or waste is also important. So again, nuclear waste is a big one, but all different sources of energy can create waste. So coal, for instance, leaves ash that's highly toxic, and that needs to be stored securely. Solar panels and wind turbines will last a long time, but eventually they'll stop working and they'll need to be landfilled or buried or recycled in some way. So when we get rid of something, that land space also needs to be taken into account. So let's consider a couple of different energy sources to see what density looks like for different examples. Hydroelectricity is an example of a source of energy that's not particularly energy dense. While a lot of us might think of the space that's taken up by the dam, far more important is basically the reservoir or water that's held back by the dam. So we don't generate a lot of power from water that's passing through. So in order to generate a lot of electricity from hydro, we need to have a lot of water. And that's why it's not very energy dense, because the amount of space that are taken up by these human-made lakes created by the dam take up an awful lot of space. This is a point that we touched on previously as well. And we pointed out that there's some problems because that space means that there's fewer ecosystems. It can mean the flooding of important lands like forests and the like. So again, hydroelectricity, while it has other advantages, is not particularly energy dense. If you've ever driven by a wind turbine installation, you may have wondered why the windmills are spaced so far apart. One of the reasons why is because of a phenomenon called wind shadow. And let's imagine that you have two wind turbines that are placed close together. On a windy day, one of those turbines will turn, but it basically means that in the area around that turbine, there's going to be less wind to turn those other turbines. So if you place them too close together, there's not going to be enough enough wind to power the second turbine. So what we have to do is we have to space them out. That's one of the reasons why, if you consider some of the calculations that have been done for the energy density of wind, why by some accounts it's one of the least dense forms of energy, because you have to space these turbines out quite a ways so that you aren't having turbines that are standing still because of the wind shadow that's created by other turbines. So again, we have to often space things apart, and that's going to reduce the overall energy density. Similar things also have to happen with solar panels. If we place solar panels too close together, they're going to cast shadows on each other, and shadows are not going to generate a lot of electricity. They work best when they have full sun. That means if you look at a large-scale solar installation, what you'll see is that the panels will be installed at an angle with generally a lot of space between them. And that space is intended to reduce the amount of shadowing of each of those panels. So what we have to do then is we have to space them out, and solar panels tend not to be as energy dense as some forms of fossil fuel generation like natural gas and nuclear for that reason. So again, we can't really get around this. We can't just pack them closer together because it would defeat the purpose of trying to generate solar power if we have too much shading. So I have hinted at some of the problems with low energy density, but I want to look at some of those in a little bit more explicit detail. So as I've pointed out, lower energy density means that energy sources take up more space. And one of the problems is that can create competition for other things that we might want to use that land for. So for example, imagine a small community wants to create a huge solar panel installation on lands that they own. That's going to mean that if they install them on the ground, basically on racks, similar to the ones that are shown here, that means that they're not going to be able to use that land for farming because the plants will need sun. Means that we're not going to be able to build homes in that area. And it also means that we're not going to have as robust a natural ecosystem. So obviously, if we had that solar panel installation, we wouldn't be able to have forests there. And one of the challenges is that sometimes energy projects can compete with other things that would help solve the global warming crisis. So as we pointed out previously in the course, forests help absorb carbon dioxide. And if we're cutting down forests to install new sources of energy, like solar panels, we're losing that other global warming fighting benefit. So we do want to be careful and try not to create competition between different kinds of energy sources. One of the things that we can do is that we can do our energy installations in areas where we may not have any other purposes for them. This is one of the reasons why in areas where there are deserts, solar panels are often installed because we don't have farming there, people don't live there, so there's less competition for those uses. Another thing that we can do is to think of ways to combine low density energy sources with other purposes. And this is one of the big advantages of wind turbines and solar panels. Many solar panels are now being installed on rooftops, sometimes they're being installed above parking lots, and this allows them to not use land because that land is already in use. So we already have a home here. We're not taking additional land if we install those on the roof. With windmills, they're frequently installed in rural areas on farmland, and the direct space under a turbine isn't very much. They're rather tall, but they're also very narrow, so a farmer does not have to sacrifice very much farmland in order to install a wind turbine. The other thing we also want to keep in mind is that when we combine low density energy with other purposes, there's often other advantages to them. Solar panels can help keep a house cool because it means that the sunlight isn't being absorbed by the roof and potentially heating up the house. It's being absorbed by the solar panels instead. So they can actually help keep buildings a little bit cooler, especially when you have a lot of panels on a roof like this. Farming is a hard way to make a living, and farmers are dependent on luck, the market, and a lot of other factors to determine how much money they'll get for their crops or their livestock. In a bad year, if a farmer has a wind turbine or wind turbines on his fields, he will still generate money from those turbines as another source of income. So when these turbines are installed, there's often a deal to pay the farmer or the landowner for that installation. So this means another source of income. And that can help protect farmers who are often very vulnerable to some of the problems in the market. So even though low energy density sources can present problems, there are often many ways to work around those problems and actually come up with other advantages to these sources of energy. So to summarize some of the key messages that we made in this video, energy density measures the amount of energy that's produced in a given area. When we talk about high energy density sources, we're talking about sources that take up relatively less land. So good examples of sources of electricity that we see being used frequently in places like Ontario today are nuclear power and natural gas. So they're able to provide a lot of energy in a relatively small amount of space. By contrast, wind, solar, and hydroelectricity tend to be less energy dense, and they're going to take up more space. As we pointed out, the fact that they take up more space can create some problems, but if we can figure out ways to combine the uses of land so we can use low energy density sources with other purposes, then we can help reduce a lot of those problems. And as I pointed out, installing solar panels on roofs or installing windmills in farmlands are two examples of how we can get around that problem of low energy density.